Welcome. My name is Ian Wright, and I am a certified senior client technical specialist with the IBM Corporation. Today we'll be taking another look at the remote copy functionality on the IBM Storwize V7000. Specifically, this time we will be looking at the tasks involved in recovering to an auxiliary site after an outage, and then what is involved in returning back to the primary site when the outage has been resolved. For purposes of this video, we'll assume that some sort of outage has occurred in Oxford 1's data center, whether planned or unplanned, that has caused us to fail over to Oxford 2. If an outage causes our mirroring to stop suddenly, the consistency group will prevent the volumes on the auxiliary disk system from becoming unsynchronized from each other. This allows us to easily recover to the auxiliary Storwize V7000 with a level of consistency similar to what we would find in a power failure situation. The applications can easily be restarted because none of the data is out of sequence, but we may need to replay some logs initially. The first thing that we'll do at this point is create a snapshot of our secondary volumes. This is because after the outage on Oxford 1, we are left with only one good copy of data in Oxford 2. Creating a snapshot allows us to recover to an earlier point if we have a corruption issue later on by using the reverse flash copy demonstrated in the Introduction to Flash Copy video. At this point, we'll assume that the incident was minor or more than likely a planned outage that was only temporary in nature. And our main data center has been restored. We've been running our remote data center for some time now, and we want to have the changes that we've made sent back from Oxford 2 to Oxford 1. The first thing to do in this case is create a snapshot of our volumes in Oxford 1. When we start sending the changes from Oxford 2, there will be a brief period where the state of data in Oxford 1 is considered to be inconsistent copying. In order to make sure that we can bring Oxford 1 back to a point of consistency in the event of an outage on Oxford 2 or the network during this copy process, we create a snapshot that we can use for quick restore in that unlikely event. Next, we're ready to synchronize Oxford 2 back to Oxford 1. In order to do this, we'll click on the Actions button and select Start. Because we are trying to send from Oxford 2, which is the auxiliary disk system in this relationship, we will select Auxiliary as Primary and click Start Consistency Group. When we reach the state of consistent synchronized, that means that the copy process has completed. This logo here means that the master and auxiliary are switched, which is to be expected because we have been using the auxiliary as the primary for this copy. But at this point, we are ready to go back to the primary data center with Oxford 1, so we'll select Actions and click Switch. This process will cause the volumes in Oxford 1 to resume their state as master or primary volumes, and Oxford 2 has resumed its role as the auxiliary. So by switching back to Oxford 1, we see that it is consistent synchronized, it is the primary, there is no switch, and we can quickly and easily restore our applications once again to the primary data center. The IBM Storwize V7000 also has the option of using our TPCR feature, which grants us enhanced management of remote copy relationships in the IBM Storwize V7000. For further information on the IBM Storwize V7000 or on TPCR, you can go to the website listed here or contact your IBM sales specialist or IBM business partner. Thank you very much for your time. And special thanks to the Advanced Technical Skills Group in Gaithersburg, Maryland, specifically Gonzalo Fuentes, Dominic Pruitt, and Bill Wiegand, for making the IBM Storwize V7000 available and for assistance with these videos.